Hello everyone. Today we're going to learn lesson 2 creating and solving inequalities. The homework that goes along with this lesson is on pages 65 to 66, and we're going to do number 2 through 20 even, and then add on number 21 and number 24 at the end. The only special instructions are in this 2 through 20 even section. We're going to add special directions to graph numbers 2 through 6. So those first three evens, 2, 4, and 6, even though the book doesn't say graph them, we're going to graph them anyway. So when we talk about creating and solving inequalities, it's a whole lot like solving just regular equations, except instead of an equal sign in the middle, we're going to have some sort of an inequality symbol in the middle. So here's just kind of a list of reference in case we've forgotten which direction less than signs and greater than signs and whatnot face. So these are symbols we're going to see in our inequalities. And like I said, it's almost exactly like solving a regular equation, except for this one really important rule that I kind of drew emphasis to right here in the middle of the page. As we're solving our inequalities today, anytime we do a step at the end of our problem where we multiply or divide an inequality by a negative number on each side, it's going to cause us to reverse our inequality sign to face the opposite direction of what it was originally facing. And then I have another little reminder right here that when we do our graphs today, and I talk about graphs of inequalities, it's not going to be like giant graphs that we do on graph paper. It's going to be the kind of graphs that we draw on number lines to show the different solutions that are possible for our inequalities. So on those graphs, a closed dot is going to indicate that the solution could equal or include the number that we are graphing. So if you see an equal bar, like a greater than or equal to or a less than or equal to sign in your inequality, you're going to use a closed dot on your graph. Anything without the equal bar under it will be an open dot on our graphs. So we're going to jump in and try some examples. Okay, if we look at inequality number 1 right here, we're going to both solve this and graph it. So like I said, we're going to solve like normal as if this was just a plain equation. It's just instead of an equal sign, we'll have this less than or equal to in the middle. So if we were going to solve for e, the first operation we would be undo this subtraction by adding 10 to both sides of the inequality. So the negative 3e would stay on the left side, the less than or equal to sign would stay in the middle, and negative 4 plus 6 would be, or negative 4 plus 10 would be 6. And then to get e by itself, we would need to divide by negative 3 on both sides. So this is that rule that I had highlighted up at the top. If we're going to divide both sides of an inequality by a negative number, it's going to cause us to leave the e, reverse the direction of this inequality sign so it says greater than or equal to, and then we would divide and get negative 2. So when we say that e could be greater than or equal to negative 2, it could not only equal negative 2, it could be any number larger than negative 2. So there's many, many, many numbers that could be greater than or equal to negative 2. So when we draw graphs, we're representing with a number line all of the different numbers that could be included in this solution. So the easiest way to draw these graphs is whatever number appears in your answer. I like to put that number right in the middle of my number line, and then just put two numbers on either side of it to make it look like a legitimate number line. And the way we would show the solutions to this is our answer could be equal to negative 2, so I'm going to do a closed dot over the negative 2 to show that it could include negative 2, and all of the numbers greater than negative 2 are to the right of negative 2 on the number line. Also notice your greater than or equal to sign actually kind of points to the right already. Your arrow therefore will point to the right, and all of these numbers that continue and extend on forever to the right of that negative 2 would be a solution of this inequality. So let's try it again. Example number 2. If we were going to solve for c, first thing we would do is undo the addition and do minus 8 on both sides of the inequality. So that would leave me with c over 2 on the left, a greater than sign in the middle, and 11 minus 8 is 3. And then to finish solving the problem, this just says c divided by 2. The opposite of dividing by 2 is to multiply by 2. So we need to multiply by 2 on both sides. We did not multiply by a negative number, so my inequality sign is going to stay the same direction as greater than, and I'm going to get c is greater than 6. Okay, so this time when we get c is greater than 6, that's going to mean that it can't actually equal 6. It can only be numbers greater than 6. So our number line to represent all of these solutions, I'd place a 6 in the middle, do a couple of numbers on either side of it. And in this case, because my answers will not equal 6, I would use an open dot to indicate that this is kind of my starting point, but it does not include the 6. And all of the numbers greater than 6 are again to the right, and it's helpful because this sign is also pointing to the right. So we're going to continue with some more examples to get into some more complex problems. And these are great examples, they just don't give a lot of room to work. So I'm going to flip to the back of my page where I have a little more space, and we're going to work out some of these examples to continue. So these are just examples from the front of the page. We're going to solve for s in this one. Okay, so when you guys look for s, we would want to get rid of the 3 first. So I'm going to subtract 3 on both sides of the equation. 15 minus 3 would leave me 12 is less than negative 4s. Now to finish it out, I would need to divide by negative 4 on both sides of the inequality. So 12 divided by negative 4 would leave me negative 3. But I just divided both sides by a negative sign, so dividing by a negative is going to cause me to reverse the direction of my inequality sign, leaving me with s by itself on the right. However, with inequalities, we don't want to leave our variable on the right because it's kind of considered backwards. We don't want to know that negative 3 is greater than s. We want to know that s is less than negative 3. So anytime we're doing one of these, we're going to make a note. The variable needs to be on the left. Okay, so my graph for this would just have a negative 3 in the middle, a couple of numbers on either side, and we would want to do an open circle because it does not equal negative 3, and in this case it's everything less than negative 3. So less than would go to the left. Okay, continuing on with number 4. To solve for this one, I would want to subtract 1 on each side and get 3/4 j is greater than 3. And just a little review of how to deal with fractions. When you have a fraction being multiplied by your variable, the easiest way to eliminate that fraction is multiply by the reciprocal. So we could eliminate this, but that means we also need to multiply the other side by 4/3. And if it's helpful to place a 1 under the 3, you can see that this numerator and denominator would cross cancel. So we're going to get j is greater than 4. And in order to graph that, we would just put a 4 in the middle of the number line, a couple of numbers on either side, and greater than would point to the right with an open circle. For number 5, we add a few extra steps. We're going to actually have to use the distributive property, and we have variables on both sides. So we're going to leave the 8c plus 4 the same, our greater than sign. And then if we distribute, we're going to get 4c minus 12. And then we don't want to have a variable on either side, so we need to eliminate either the 8c or the 4c. Typically we go with the smaller number. So to get rid of 4c, we're going to subtract 4c on both sides. So 8c minus 4c is 4c, plus 4 is greater than negative 12. We would subtract 4 on each side to get 4c is greater than negative 16, and then we would divide by 4. So c is greater than negative 4, And to graph that, I would just put a -4 in the middle, an open circle on the -4, and greater than would point to the right. Okay. Continuing on with one more that has a few extra steps. I'm going to do distributive property on this one first to get rid of the parentheses. So we're going to have 5x minus 5 is less than 3x plus 10 minus 8x. We would want to combine the like terms on this right side, so I'm going to leave 5x minus 5 the same. And 3x minus 8x is -5x plus 10 for the right side now. And then again, we have an x on either side, which is not going to work. So we need to either eliminate the 5x or the -5x. I'm going to do the -5x since it's smaller. So we would get rid of that by adding 5x to both sides, leaving us with 10x minus 5 is less than 10. Then I would want to add 5 to get 10x is less than 15. And finally, divide by 10. And since this was not a decimal problem to begin with, we will not write it as a decimal answer. We will just simplify this fraction and end up with 3/2. So this is a good example because if you end up with fractions for your answer and you're worried about how to graph that, I would just count on my number line using fractions as well. So I would put 3/2 in the middle of my graph, and then you can either say like 3/2 is like 1.5. So then you could have 2 and 5/2. You could have 1 and 1/2. So if you get fractions, like if you got 1/3, count by 1/3, 2/3, and so on. If you get a fraction, count by fractions, and that'll make your number line nice and easy. Open circle this time, and an arrow to the left for less than. Okay. One more like this before we take a look at a word problem. If I was going to solve this for t, we would add 3 to both sides and get 0.6t is less than 18. We would divide by 0.6 on each side. And even though it started out as a decimal, this actually divides nice and evenly. And 18 divided by 0.6 comes out as 30. So on this number line, I would put 30 in the middle. This would have an open circle, and we would have an arrow left for less than. Okay, for the last section of these notes, we're going to take a look at what is involved in actually creating and solving an inequality that matches a situation. So off of page 63, we're going to take a look at the word problem number 4 in the middle of the page. For number 4, the situation we have here says that Zachary is planning to send a video game to each of his 2 brothers. If he buys the same game for both brothers and pays $4.75 to ship each game, how much can he spend for each game without spending more than $100? Write and solve an inequality for this situation. So the thing that makes this an inequality instead of an equal sign is this part right here that says that he wants to be able to do this without spending more than $100. So if someone has kind of set a budget of $100, they know that they don't want to go over $100. So that kind of tells me they would be okay with spending $100, but nothing more. So in other words, with an inequality sign, that would mean they would want to spend less than or equal to $100. So when I write my inequality here, I'm going to make sure I include less than or equal to $100 at the end of it. And then we're going to reconsider what he's buying. It says he's going to buy a video game. So he's going to have to pay for the video game. Plus it's going to cost him $4.75 in shipping charges. But he has 2 brothers. So the easiest way to write this would be times 2. So to solve this, we would do a quick distributive property here and have 2v. If you multiply 2 times 475, it comes out as $9.50. Then we would want to subtract out the $9.50 on each side to get 2V is less than or equal to $90.50. So now if we divide by 2, it will tell us the cost that he could spend on each video game. If you do 90.50 divided by 2, it comes out that he could spend $45.25 on each of the video games or less, and he would stay underneath his $100 budget. Okay, one more example of this comes from page 64 in the Your Turn section. It's problem number 8 about a fundraiser. On problem number 8, okay, it says the school band will sell pizzas to raise money for new uniforms. The supplier charges $100 plus $4 per pizza. The band members then sell the pizzas for $7 each. Write and solve an inequality to find how many pizzas the band members will have to sell to make a profit. So this problem, we want to think for just a second about how profits work. Okay, in a fundraiser, you obviously need to sell your product for more than what you paid for it. So we know they're selling the pizzas for $7 each, and we need the amount that they make off of that to end up being more than or greater than the amount that they paid from the supplier to get the pizzas. So let's set that up as an inequality. We're saying that to make a profit, we need their $7 per pizza that they're charging to be greater than the $100 plus $4 per pizza that they paid to get the pizzas from the supplier. Now, if we solve that, that will tell us how many pizzas they need to sell. So I have a 7p and a 4p. I can't have a variable on both sides. So let's eliminate the 4p by subtracting 4p on both sides. So that's going to leave me with 3p is greater than 100. And then I'm going to divide by 3. So if I do 100 divided by 3, it does not come out nice and evenly. It comes out as like 33 and a third or 33.3 repeating. So we need to be logical when we're answering questions like this and recognize that the band can't actually sell 33 and a third pizzas to make a profit. Okay, we also need to be wise enough to go, okay, well that would round to 33, but 33 pizzas would make them under the amount needed to turn a profit. So we would have to say the band must sell at least 34 pizzas to make a profit. And that is how we create and solve and graph inequalities.